Hello students. Previously we saw that hydrocarbon compounds are classified as saturated and unsaturated. Saturated ones have all carbon-carbon single covalent bonds and are together called alkanes, while unsaturated it has at least one double or triple bond between their carbon atoms. They are respectively called alkenes and alkynes. We left a question for you there. If you are given three solutions, can you tell me which one is saturated or unsaturated by simply looking at it? For any solution, we know that we cannot see and identify whether it has a single bond, a double bond, or a triple bond. So how do we know if solution is saturated or unsaturated? That is, it has single, double, or triple bond. So for this, we need to perform certain identification tests, and then we can distinguish between saturated and unsaturated carbon compounds. Let us conduct an experiment to understand more about this test. First of all, place the solutions of alkane, alkene, and alkyne in three different test tubes. Now add few drops of bromine water to each of these test tubes. As you can see, it is brown in color. And what happens after some time? We observe that there is a change in the color of the solution in test tubes 2 and 3. So we can say that bromine water becomes colorless from brown. But why do you think this color changed? We have learned that unsaturated compounds are reactive because they have double or triple bonds, and they are more reactive as compared to single bonds. Thus, they can break easily. So these compounds take part in chemical reaction with bromine water very instantly. And that's what happens here. The moment bromine water is added to the test tube, having unsaturated hydrocarbons, ethene and ethine, they readily react with each other and a color change is indicated. Now let's have a look at a chemical reaction here to have a better understanding. During the reaction, the double bond in ethene and triple bond in ethine breaks. The moment bromine water is added, bromine ions are formed and they make new bonds with the carbon atoms having double and triple bond in the respective compound. As you can see, one bond in ethene breaks, setting free one valency of each carbon. Bromine bonds with them here, which results in the formation of the compound dibromoethane. Now wait, why this name? It's because it has two bromine atoms indicated by dibromo, and due to this double bond now becoming a single bond, ethene becomes ethane. The same happens with ethine as well. However, if one bond breaks, dibromoethene is formed, and if two bonds break, tetrabromoethane is formed. Here, di and tetra indicate the number of bromine getting added, which is 2 and 4 respectively. And ethene and ethane shows formation of new alkene and alkane compounds respectively. Again, as you can see here, with the successive addition of two bromine atoms, the triple bond breaks to a double bond, resulting in an alkene compound, and a further single bond resulting in a corresponding alkane compound. Now observe the first test tube. We can see here that color in the first test tube, which has alkane compound ethane, does not change. This is because at room temperature, there is no reaction between two reagents. Thus, the color of bromine water does not change. Do I mean always there is no reaction? No, this is not true. When the same mixture of ethane and bromine water is heated slightly, or if it is kept out in presence of sunlight, we see the color of bromine water becomes lighter. This indicates that some reaction does take place here. Now, why is this so? This is because this external heating or sunlight acts as a source of energy to break bonds in saturated hydrocarbons. and then only new ones are formed with the bromine. As we know, saturated compounds are relatively stable and less reactive as compared to their corresponding unsaturated compounds. They require additional energy to take part in reaction. So from this identification test, we also found one important characteristic of saturated and unsaturated carbon compounds. Alkanes are less reactive than alkenes and alkynes. Now you may be wondering, less reactive? We just said that alkanes are saturated and thus they are stable and can no longer make new bonds. So how can they be called less reactive? They should be inert, right? But sadly, that's not the case. Saturated compounds are indeed stable since all their capacity to form new bonds is lost. But with little energy, these existing single bonds can easily break and hydrogen can be replaced with any other atom or group of atoms. And that's what we saw with ethane as well. But of course, this reactivity is less than the reactivity of unsaturated compounds. Against this, the unsaturated compounds can form new bonds and react even at room temperature instantly to form new compounds. Thus, they are more reactive. We can conclude that the weakest bond is triple bond. Thus, alkynes are most reactive. The strongest bond is a single covalent bond. Thus, alkanes are the least reactive compounds. So this is all about identification test of saturated and unsaturated compounds. It said, if the color of bromine water changes, the given compound is unsaturated. Either an alkene or alkyne is there. And if the color does not change, the given compound is saturated, that is, they are alkane compounds. These saturated and unsaturated carbon compounds are classified based on the bonds they form. Well, we will learn this in our coming videos.